Fetchers of America, you're going to call me the King Fetcher on this one because our last and final section, and you're going to be like, are you kidding me, is word problems. Yes. I'm sorry, but the nice thing is that these will be incorporated into the test, which isn't nice. You're going to have some. We're going to review it really thoroughly. But you've seen most of this before. It should be very review for you. I'm going to show you this really quick. In section 5.8, I have three sets of or types of word problems that we're doing. So, for instance, if you notice, you're doing numbers 1, 2, 3, and 4 in the homework. Okay. So numbers 1, 2, 3, and 4 are geometry problems, and we're going to do number 2 right now. We're going to do number 2. Numbers 19, 21, and 23. Numbers 19, 21, and 23. These are consecutive integer problems. And then we're going to do some Pythagorean theorem problems. 25, 26, and 27. So this is number 25, 26, and 27. So we're not going to do the whole section of word problems. We're going to give you 3 or 4 practice problems because you've got problems like this on the test. So I want to give you plenty of practice. So we're going to do one each. We're going to do one geometry, one consecutive integer, one Pythagorean theorem. We're going to talk to you about the Pythagorean theorem. Such a cool theorem. Lots of fun. You guys are like, ooh, woo, yeah, lots of fun. Fetching word problems. I hate you. I don't blame you. I feel for you. Okay? So we've always kind of put people's names in these to make this a little bit fun. So I'm thinking, my sister out there, Sister Bravo, Paula Bravo from our 2 p.m. class this semester, you better be watching, okay? So we're going to say the length of, but Paula's rectangular garden is 4 meters greater than the width, okay? So hopefully you grow a garden this year since you're all in quarantine and you don't want to buy produce at the store because you're worried about it being infected or something. I mean, we're living in World War Z. I mean, it's crazy. I hope you're all safe and doing good. This corona stuff's getting, it gets a little overwhelming at times. But listen to the prophets and apostles this weekend. General conference, going to be good. Going to bring a lot of hope and faith and positivity into your life. So the length of Paul's rectangular garden is 4 meters greater than the width. We want to talk about geometry problems. They love to make comparison statements. So we're saying, the length, okay, is 4 meters greater than, right, which means more than, which is plus, not the more than sign, but plus the width. So we think about length is means equals 4 plus W, right, because it's 4 meters, so we can just get rid of that. It's 4 plus W. We're talking about area. Area. Can I just share something with you? If you go back to chapter 2 and look at our word problems, every word problem was perimeter. We couldn't do area before because area is the multiplication of length times width, which can create a variable times itself, which creates an x squared or an L squared or a W squared. We'll see this, and it creates a quadratic equation. So if we have area equals L times W, and I tell you that the area, if we come back here, is 96, and L, okay, is 4 plus W, so this is, 4 plus W, which is times W, right? Because length is 4 plus W, L equals 4 plus W, and this is times W. Yes, the distributor can be on the tail end there. It just goes, it's just like putting it in the front, put it in the back. It goes to everything in the parentheses. It has to go to here and to here. And so this ends up being 96 equals 4W plus W squared. And so you see, we've created a quadratic equation, which in the past we never knew how to solve, but now we do. So we're going to subtract 96 from each side. We talked about this. It's okay if zero's over here. We're going to put this in descending order. So the W squared is going to go first. The 4W is going to go next. The minus 96 is going to go last. Okay? Now, I want you guys, to take a moment and see if you can factor this. Okay? So let's go ahead and do a quick pause. Quick pause, Jordan. All right, so Jordan's brought you back here. So check it out. C equals negative 96, B equals 4. If you remembered your times tables, 12 and 8 make 96. 12 and negative 8 make negative 96. When added together, make 4. And so now we know that we're going to have, 0 equals, parentheses and parentheses. We need W squared, so we have W and W. We have plus 12. We have minus 8. And so we, in essence, have W plus 12 equals 0 or w minus 8 equals 0. So here we subtract 12, we subtract 12. We're going to get w equals negative 12. And over here we're going to add 8 and add 8. And we're going to get w equals 8. I need everybody to pay attention to this. This is powerful. This is why we're going through these problems. You can handle this. You've got a few to practice. I want to show you. You have an even problem, 2, an even problem, 4, an even problem, 26. In your announcements, in your assignment, okay, in Canvas, I give you the even answers so you can check these. And this is, we're doing number 2 together right now. But here's the thing. The width equals negative 12. The width equals 8. 2 solutions because of degree 2 equation. But I want to ask you guys, if you've got a rectangular garden and this is 8, okay, right? So if we say, hey, guess what, folks? The width is 8. 8 plus 4 makes this 12, right? But tell me something. Can I have negative 12? Can I have a negative 12? No, negative 12 is not an option. There's no such thing as a negative dimension. And so this answer eliminates itself. And this was described in the back of the packet. And now you see what we're talking about. In the real world, okay, a negative value cannot exist. There's no negative dimension to your garden, okay? That would be, you know, like bad food or something, moldy food. I mean, no, we're not going to do it. So in the end here, okay, the width was 8, and 8 plus 4 makes 12. So we say, well, 12, that was kind of like a 12. Yeah, I get you, but the answer is width is 8. This answer eliminates itself because it's negative, okay? And then we plug that 8 into 4 here to get the length, because they ask for both the length and the width, okay? Cool, let's hit pause. Okay, folks, so in numbers 19, 21, and 23 in section 5.8, you're going to have a consecutive integer problem. Do you remember consecutive integers? If you remember, if we have 2 consecutive integers, okay, the first is what? Do you remember? We always start with x. That's right. So the first is x, and the second then would be x plus 1. So if you had a number like 7, 7 plus 1 would be 8. Those are 2 consecutive integers. Now, notice that this problem says you have 2 consecutive even integers. And if you remember that, we had 2 consecutive even or odd integers, because those will end up being the same configuration. Evens and odds will be the same. The first is still x, because it doesn't say we sometimes start with x. We always start with x. And our second now, because it's even, will be x plus 2. If it said odd, it would not be x plus 1 or x plus 3. It would be x plus 2 as well. We talked about that. You know, if this was 2, 2 plus 2 makes 4. If this was 1, the next odd number would be 3. 1 plus 2 is 3, right? Okay, so I'm going to erase that, okay? But there's your 2 integers. So we have 2 consecutive integers. Our first then is x. They're even integers, and so our second will be x plus 2. And it says that the product, now product means we're multiplying. And again, if you go back to chapter 2 and look at the word problems we did, they were always the sum, okay? Because we couldn't do product, because when you multiply an x times an x, you get an x squared. And this makes a quadratic equation. And so it says the product, so we think about this, if we're taking the product, those crazy sounds, okay? And so if we take the first and we multiply it times the second, that's going to equal their product, okay? All right. So our first is x, our second is times x plus 2, and their product equals 168. All right? I want you guys to take a second and see if you can finish this problem up, okay? And so let's hit pause for just a second. Go for it. All right, so here we have this. We talked about in this our process that was up here previously when we're solving a quadratic equation. We actually have to multiply this out, distribute the parentheses. X times x is x squared. X times 2 is plus 2x. This equals 168. It is not in standard form. We have a degree 2, so we got to get in standard form. Subtract 168. Subtract 168. We get x squared plus 2x minus 168 equals 0. Okay? And then we got to factor this. And you're going to need your calculator. So 168 does not factor pretty. Okay? So we ultimately have c equals negative 168 and b equals 2. And so you got to start fetching around here with this. It ends up being, did you get it, Jordan? 2 numbers that multiply together make 168 when added together make 2?
I have
Okay.
no idea.
So it's going to end up being 12 and 14. 12 and 14 make 168. Do that on your calculator, some of it's true.
It's true.
Yep, 168. And you guys at home are like, how did he know that? Because I cheated. I looked at the answer. How do you like me now? Okay? And so this is going to be a negative 12 and a positive 14 makes negative 168 when added together makes 2. Which means that we're going to have a parentheses and a parentheses set equal to 0 because we just took this equation here. We have to have x and x to make this x squared. Okay, and then the negative 12 and the positive 14 come down. We solve this, we apply the principle of zero products. X minus 12 must equal 0, or x plus 14 must equal 0. Here we add 12 and we add 12 and we get x equals 12. Here we subtract 14 and subtract 14 and we get x equals negative 14. Folks, please pay attention to this. In the geometry world, we had to eliminate this. But we're not asking for a dimension to a geometric shape. We're asking for a consecutive integer. What's the definition of an integer? It is a positive or a negative whole number. Okay? So can this be an answer? Absolutely. Can this be an answer? Of course. Okay? So our first answer is 12. And if we plug 12 in, 12 plus 2 is 14. Okay? There's our first set of consecutive even integers when multiplied together make 168. But Jordan, I want you to get your calculator out again and check this out, okay? If we have x is negative 14, I want you to look at this. What's negative 14 plus 2? It's negative 12, okay? So what's negative 14 times negative 12? Look at that, negative 14 times negative 12. Well, it also makes positive 168, right? So if you think about this, if we have two consecutive integers, and their product is 168. 12 times 14 makes that, but negative 12 and negative 14 make it as well, okay? And I want you to recognize this is the order it goes in, because we go from smallest to largest, and in the negative realm, negative 14 is smaller than negative 12, where in the positive realm, 12 is smaller than 14. This is your first set of answers. This is your second set of answers, okay? Take some time, study that out. You got a couple others you can practice. We just did number 21 together. Let's pause for a second. My main man Jordan got us going again. Check it out. There is a theorem in math called the Pythagorean theorem. It was created by a man named Pythagoras. Okay, and he determined that for all or every right triangle, okay, for all right triangles. Okay, what's a right triangle? Do you know, Jordan, what's a right triangle? It's a triangle with a right angle, and a right angle is a 90-degree angle. Okay, so you'll see this little, square down here. Okay, so other, right triangles. I mean, basically, this is a right triangle right here. Okay, but is this a right triangle? No. Okay, unless this was a 90-degree angle up here, but it's not. Okay, so that is not a right triangle. These are right triangles because they have right angles. So what's interesting is the right angle has two legs to it. Okay, these are the legs that comprise this 90-degree angle. There's one side of the 90-degree angle, there's the other side. They're called the legs. The opposite side, the longest side, is known as the hypotenuse. Okay? This is the only time at BYU, Idaho that you can get high while using pot. Okay? Don't tell your parents. Okay, stop it. The hypotenuse. Okay. Brother Rich's bad humor. Okay? So, check it out. The Pythagorean theorem says that the leg squared plus the leg squared always equals the hypotenuse squared. Sometimes people call this A, and they call this B, and they call this C. C is always the hypotenuse. A and B, can move around here. So ultimately they can say A squared plus B squared equals C squared. The C is always the hypotenuse. Okay? In construction, if any of you have ever been involved in construction, construction guys know this rule. They just don't know it's called the Pythagorean theorem. They call it the 3-4-5 rule. And I'll tell you why they call it the 3-4-5 rule. Because 3, 4, and 5 are the first integers that make this true, okay? And so basically what we're saying is, and I want to show you this, it's kind of a cool thing. If I told you that this leg was 3, okay, we say A equals 3, and I told you that the hypotenuse was 5, okay? And so, and then this one we say, I don't know what it is. Well, I can tell you it's 4, but we can say, well, B equals B. We just don't know what it is. It's a question mark, okay? And so we could say, well, A squared is going to be 3 squared. And B squared, well, that's just going to be B squared because we don't know what that is. And C squared is going to be 5 squared. So 3 squared, everybody, is 9. And B squared stays B squared. And 5 squared is 25. If we go to solve this, right, check it out. Okay, this is kind of cool. We're going to, in essence, you know, kind of blow your mind here a little bit. We have a quadratic equation here. We subtract 25 from each side. And usually you'd be like, well, don't we bring the 9 over there? Just watch this. Okay, because we have a b squared, we got to get it all on one side in descending order. 9 minus 25 makes negative 16. So we're going to say b squared minus 16 equals 0, because we got to put it in descending order. 9 minus 25 makes negative 16. B squared is positive. This equals 0. Then we factor this. Well, this is a special case. Okay, and so we take the square root of b squared, and we get b, and the square root of 16, and we get 4. Jordan, are you ready to sing it? Come on over here, Jordan. Come on over here, man. Okay, let's do it. Let's stir the pot. Okay, you guys ready? 1, 2, 3. Put it in a sum. Put it in a difference. Yeah. Okay, so we put this in a sum. We put it in a difference. Okay, can you still see this, Jordan, all the way over here? Equals 0. Is that in the camera? Okay, cool. And so ultimately, b plus 4 equals 0, or b minus 4 equals 0. We subtract 4 from each side. We get b equals negative 4. Can we have a negative geometric dimension? Can b equal negative 4? Nope. So that one cancels itself out because it can't be negative. Here we add 4 and we add 4, and b equals 4. So the reason they call it the 3, 4, 5 rule is because if the hypotenuse is 5 and this leg is 3, then we know this one's going to be 4. If this one is 3, that one's got to be 4. 3, 4, 5. The two legs will be 3 and 4, the hypotenuse 5. And those are the first integers that make this true. Okay, so that's why they call it the 3, 4, 5 rule. So we've taught you the Pythagorean theorem. We're going to pause for a second and put a word problem up where we got to use the Pythagorean theorem. Let's roll. All right, Fetchers of America. We're going to do, so now you've got a Pythagorean theorem problem, and we're going to help you with number 26. It's kind of a nasty little sucker, and yeah. Cool. So check it out. It says Elliott Street is 24 feet wide when it ends at Main Street in Fetcherville. They didn't say Fetcherville, but they had some other big old name, and I don't want to mess with it, you know, so it's Fetcherville. A 40-foot long diagonal crosswalk allows pedestrians to cross Main Street to or from either corner of Elliott Street, find the width of Main Street, and it tells you to look at the diagram. So I'm going to help you. We're going to draw this out, okay? And so if we have a big old street here, and then we have a big old street here, and you got to understand, let's say that this is Main Street, okay? So this is Main Street, and this street here going down this way, this is Elliott Street, okay? Now what you got to understand here is they're telling you that Elliott Street is 24 feet wide. So from here to here, we know is 24 feet. They're telling you that there is a diagonal crosswalk that crosses, you know, from here to here, and it is 40 feet, okay? So we know the width of Elliott Street, but then they want to know the width of Main Street, okay? So if we look at this in essence, okay, the width of Main Street, you could take it right here. You could take this triangle right here and say, okay, look at this. This is 24, this is 40, and Main Street's width is right here, going across here. It's X. It's what we don't know. Okay, this is a right triangle, because anytime you have two streets meeting each other at 90-degree angles, right, it becomes a right triangle. They don't tell you that they meet at 90-degree angles. Not all streets, I mean, these streets could have been at angles, you know, they could have been like this, but most streets meet at a 90-degree angle like that, and so they're assuming that. You know what assuming does, right? You can look that one up. But check it out. So what we're ultimately saying, the legs, okay, so remember, leg squared plus leg squared equals hypotenuse squared. So tell me what one of my legs is, Jordan. What's one of the legs of the right triangle?
24.
Okay, so we got 24 squared plus what's another leg?
B squared.
B or X. Okay, so we picked X here. It's fine. You could have had B. And then what's the hypotenuse?
40 squared.
Very good. So 40, and we're going to square it. And so we get our calculators out. Go for it, Jordan. What's 24 times 24? Okay.
576.
576 plus X squared. And 40 times 40? 1,600.
1600.
Okay. And then keep your calculator going, all right? So now we've got to, I want you guys, for just a second, I want to see if you guys at home can finish this problem, okay? Go. Pause it. Okay, so hopefully you worked on this a little bit, all right? You can do this one of two ways at home, but if we stick with our solving quadratics thing, okay, we're going to subtract 1,600 from each side. And when we do that, 576 minus 1,600, we're going to get negative 1,024 plus x squared equals 0. Now we need to put that in standard form. So we're going to have x squared minus 1,024 equals 0. And in essence, this is a binomial. We're hoping that's a perfect square because we know x squared is. And so what you ought to do is you ought to plug 1,024 into your calculator and take the square root of it and see, is it a perfect square? Is it, Jordan?
Yes.
Yes. And what is the square root of 1,024?
32.
32. Good job, Jordan. And so, in essence, we take the square root of x squared, we get x. The square root of 1,024, and we get 32. Sing it with me, Jordan! 1, 2, 3. Put it in a sum, put it in a difference. Good job. Okay, and so ultimately then we apply the principle of zero products. X plus 32 equals 0, or x minus 32 equals 0, and we're going to subtract 32, subtract 32. We get x equals negative 32. People, can we have a negative value to a triangle? No, so that one's out. Okay, so we're going to add 32 and add 32, and we get x equals 32, and that is our answer. The width of this street, right, from here to here is 32 feet, because we can use the Pythagorean theorem to do it. All right, guys, good luck on this assignment. We'll catch you on the final review, or the last test review, chapter 5, in our next video and our final video. See you then.